Algebra 2, 6-5, operations with radical expressions. So I'm going to write on the top here, n is greater than 1. The nth root of a times b equals the nth root of a times the nth root of b. So as long as the index number is greater than 1, then the nth root of a times b is the same as the nth root of a times the nth root of b. And so we're going to use this to do a bunch of examples, and that's what we're doing here for 6-5. We're just doing a bunch of examples. So first off, we're going to do a little bit of a clarifying example. The third root of negative 27 equals negative 3, right? Because negative 3 times negative 3 times negative 3 is negative 27. Now, the fourth root, though, of negative 16, this number needs to be positive. So if you have an even number for your index number, then your radicand needs to be positive. So that's a no solution situation there. Okay. Simplify. We've got an example, and it is the square root of 32 x to the 8th power. Okay, so 32 is 2 times 16, and 16 is 4 times 4. So I got the square root of 16 is 4, and I've got this 2 left over. Okay, so that means I get a 4, square root of 16 is 4, and then this 2 stays inside here. 8 divided by 2 is 4, so 4 times x to the 4th power. That all looks good. Now I need to take care of this 2, and that one has to stay inside the radical. And so that's my answer there. You try this one. The square root of 12, c to the 6th power, d to the 3rd power. So this is the square root of these guys. Okay, so go ahead and pause and try to do this one. Okay, let's see how you did. Okay, so this 12, there's no good square root of 12. So I've got 2 times 6, 2 times 3. Okay, I've got a 3 here, and I've got 2 2's. So the 3 is going to have to stay inside the radical. 2 can come out. All right, so I've got 2, and then 6 divided by 2 is 3, c to the 3rd power. D divided by 2, 3 divided by 2, that's no good. But we can rewrite this d here, d to the 3rd, as d times d times d. And so I could take 2 of those d's out. The square root of d squared is 2. And we end up with 1d that's left still inside there. So d squared, the square root of d squared is d. I think I said 2 a second ago, sorry. The square root of d squared is d. D times d, okay, square root of d times d is d. And then I end up with a d left over and a 3 left over that don't get to come out from under the radical. So 3d. All right, let's do another example. I've got the 4th root of 16, a to the 24th, b to the 13th. All right, so 16 is 2 times 2 times 2 times 2. So that's 2 to the 4th power. And then I'm going to just divide 4 from 24 to get my a. And then b, I've got 13 here. So I'm going to think of this b as b to the 12th times b. Right? That'll get me b to the 13th, because remember, when we multiply, we add the exponents. All right, so let's do each of these little pieces here. 2 to the 4th, the fourth root of 2 to the 4th is 2. The fourth root of a to the 24th is 24 divided by 4, which is 6, a to the 6th. And then here I've got 12 divided by 4, which is 3, so I have b to the 3rd. And then I just have this b here left over, this one sad little b, and that's the only one that goes in there. Good, let's keep going. Let's give you one to do on your own now. The third root of this 27, y to the 12th, z to the 7th. All right, go ahead and pause and do this one here, see how you do. All right, the third root of 27 is 3. The third root of y to the 12th is y to the 12 divided by 3, which is 4, y to the 4th. Now this z here, I'm going to rewrite this as z to the 6th times z to the 1st. So 6 divided by 3 is 2, so I've got z to the second power, and the z to the 1st is left over. Has to stay. Oh, you know what? There's something I forgot right here, and there should be a third root right there. And I forgot to do that over here as well. This should be the fourth root, not the square root of b. Yikes. I wonder if I did that on another lesson too. I forgot that. Wow, okay, let's keep moving. Example. Next one here, I have the square root of x to the 6th over y to the 7th. So this is the square root of these two. So let's go ahead and take each of these individually here. So the square root of x to the 6th, or 6 divided by 2, is x to the 3rd. Now, y to the 7th, I have a problem here. This is y to the 6th times y to the 1st. So I just try to get this power here to divide evenly with whatever my index number is. So this is 2. So 6 divided by 2 is 3. So I have y to the 3rd times the square root of y, because that's what's left over here. So I've got the square root of y. Now we have a problem, and that is we're not allowed to have the square root sign in the denominator. So we need to multiply the top and the bottom both by the same thing, the square root of y. So square root of y divided by the square root of y is 1, so we can multiply fractions by 1 all day long. It's fine, it doesn't change the fraction. But this way, what we're doing is rationalizing the denominator. We're taking away the radical sign. So square root of y times the square root of y is y. So that means I have y to the 3rd times y, which is going to give me y to the 4th. And then in the numerator, I have x to the 3rd times the square root of y. And that is my answer. You try that. The square root of a to the 4th over b to the 3rd. See how you do on that one? Go ahead and pause and get to work on that one. All right, let's see how you did. Let's look at the numerator first. A to the 4th, the square root of a to the 4th is a squared. You can say 4 divided by 2 is 2. Now b to the 3rd, I'm going to break that one up into b squared times b to the 1st power, or just b. The square root of b squared is b, and then I have this other b left over that stays inside the radical. Now I need to rationalize this denominator, so I'm going to multiply the top and the bottom by the square root of b, and I get a squared times the square root of b on the top, and on the bottom in the denominator I've got the square root of b times the square root of b, which is b. b times b is b squared. All right, more examples. We got about 4 more examples total before we're done with this lesson. Here comes another example. The fifth root of 3 over 4y. Okay, the fifth root now of 3 over 4y. There's nothing I can do to this 3, the fifth root of 3. And there's not much I can do to this down here at the bottom. So the deal here is I've got to figure out how to rationalize this denominator, because if I was to rewrite this, it would be the fifth root of 3 over the fifth root of 4y. And I can't have the radical in the denominator. I'm not allowed. So I've got to think, what do I multiply by this to get this fifth root out of here? So let's multiply here. I'm going to multiply by the fifth root of, now I'm going to, there's a couple ways to do this, but I'll do it this way. So let's say this is 2 squared. So now I got to think about, what do I need to multiply to get this to be a something to the fifth? So I'm going to multiply this by 2 to the third. So if I multiply 2 to the third by 2 to the second, then I add the powers, the exponents, and I get 2 to the fifth. And that's what I want. So I'm going to get 2 to the fifth here. And then I also need to figure out what to do with this y. So this is y to the 1 power. So I need to multiply it by what's left over, 4. Y to the fourth times y to the first is going to get me y to the fifth. And y to the fifth root of y to the fifth is y. So now I'm all set up for what I need to multiply. And what I do to the bottom, I've got to do also to the top. 2 to the third, y to the fourth. Okay, now if I multiply these across here, I'm going to have the fifth root of 2 to the fifth times y to the fifth. And on the top, I'm going to have the fifth root of 3 times 2 to the third, y to the fourth. All right, now I'm almost done here. I did this step because I wanted you to see 2 to the fifth and y to the fifth. Now, since these are both to the fifth, I can take the fifth root of both of them. So in the denominator, the fifth root of 2 to the fifth is 2. The fifth root of y to the fifth is y. And so my denominator looks just fine. And now I'm going to do my numerator, which is just like this, what we got up here. I can simplify this as 8. 2 to the third is 8. And so I'm going to say the fifth root of 8 times 3, which is 24, times y to the fourth power. This looks a little bit different than the answer in the notes, but it's fine. All right, you try. The cubed root of 2 over 9x. Okay, you try that one. Just very similar to the one we just did here. And let's see how you do. Go ahead and pause and get to work. All right, let's see how you did. So the first thing I'm going to do is rewrite this as a cube root of 2 over the cube root of 9x. And then I'm going to think about this 9x as 3 squared. And once I've done that, I need to think about what do I have to do to get this to be cubed, and what do I have to do to the x to get that one to be x cubed. So, well, I'll multiply here. So, well, yeah, okay, we'll do it right here. So if I want 3 cubed, I just need to multiply by one more cube root of 3. So then I'll have 3 times 3, which will get me 3 to the 3rd power. And then x, I need to an x squared here. So x squared times x is going to get me x cubed. And then I get what I multiply on the bottom, I have to multiply on the top. And so now let's get all this multiplied here. So 3x squared times 2, so I've got the cubed root of 3 times 2, which is 6x squared. Did I say x cubed? I don't remember. Now let's multiply these together. The cubed root of 3 times 3 squared, which is 3 cubed, and then x squared times x, which is x cubed. Now, I'm okay to say the cubed root of 3 cubed is 3, and the cubed root of x cubed is x. So my denominator is 3x. My numerator is just what you see there, the cubed root of 6 times x squared. Whew. All right, 2 more examples. I've got 5 times the cube root of negative 12 a times b to the 4th times 3 times the cube root of 18 a squared b squared. Now, anytime you see a negative inside the radical, take a second to make sure it's okay. This is the cubed root, so it's okay to have a negative in here. If this index number was even, then you can't have a negative in here. This would be a big no-no, a big undefined or whatever. But since this is an odd number out here as the index number, the radicand can be negative. It's okay if it's negative. All right, let's do this multiplication here. So first I'm going to do these numbers on the outside. 5 times 3 is 15. Now I'm going to look at the stuff inside the radical. So since these are both cubed roots, I can multiply all of this stuff together. So I'm not going to multiply 12 and 18, and you'll see why in a second. So negative 12 times 18. I'm just going to put those next to each other because that's going to be easier for me in a minute. But the other ones I'm going to multiply. A times a squared is a cubed. And then b to the 4th times b squared is b. I add the powers. So when I multiply, I add the powers. 4 plus 2 is 6. All right, now I'm going to look at this 12 and this 18. So this 12 is 2 times 6, 2 times 3. Okay, and then this 18 is 2 times 9, 3 times 3. Okay, and I've got this negative 1 here as well that I need to write as part of my factorization. So I'm also going to put a negative 1 right here as part of this thing. So anytime there's a negative, make sure you include a negative 1 in this mess. Okay, now let's find, I need groups of 3. So I need, okay, I've got 3 3s here, and I've got 3 2s here. All right, that's great. Okay, so that means I can take these 2's out, I can take these 3's out, I can also take this -1 out. So I've got 15 times 2 times 3 times -1. Why can I take the -1 out? Because -1, the third root here, -1 can be -1 times -1 times -1. And that would be -1. So the cubed root of -1 is -1. So I can take that -1 out. I don't know if that made any sense to you, what I just said, but it makes perfect sense to me. Okay, a to the third, the cubed root of a to the third is a. The cubed root of b to the sixth, 6 divided by 3 is 2, b squared. Now I've taken care of all of the cubed root stuff, and I just multiply this across, and I'm all done. So I've got 15 times 2, which is 30. 30 times 3 is 90. 90 times -1 is -90. And then I just have a b squared left over. Whew, that was a good one. One more example, and we are done with this section. The square root of 98 minus 2 times the square root of 32. All right. Now, there is a question that looks so much like this on the test, I remember. But so here's how we do this one. I'm going to start factoring this. 2 times 49 is 98. And we can recognize, hopefully, that 49 is 7 times 7. So we've got a 2 left over there. Now let's look at this one. 32 is 2 times 16, which is 2 times 8. And 8 is 2 times 2 times 2. Okay, now this is the square root. So I've got these 2's and these 2's. And I've got one more 2 left over. Ooh, isn't that nice that I have a 2 left over in each of these? Let's see what that means. So the square root of 7 times 7 is 7. So I've got 7 square root of 2. So that takes care of this mess. Minus 2 times 2, which is 4. And I already have a 2 out here, so 4 times 2 is 8. Times the square root of this 2 that's left over in here. Now, see, notice how I have the same radical here? So that means I can combine these two terms. So 7 times the square root of 2 minus 8 times the square root of 2 is -1 times the square root of 2, or just negative square root of 2. And that's how you do that one. And that is all we're going to do for 6-5.